We'll be right back after this important word.
A joint. Ever had one? It really sets you up, especially at breakfast time. That lovely mild flavor. Gets you up quicker than anything that does. Up and away. A good joint sends you off to a flying start. Puts you way out ahead of the rest of the crowd all day. Gives you energy to keep you going. Joints. Grab a basket and nip along to the grocer's.
Hey, welcome to episode 20 of season 5 of the Operation Grow Show. It's going to be one where we get back into taking a look at like plant breeding in terms of selection criteria. Well, selecting plants and the different ways of, well, say the different ways, so we one of two ways of doing it, and what some of the advantages might be and what some of the challenges are. Take a look at it again. I'll be writing some software to try and make it so that we can visualize it, and then like actually try and do some of the stuff, like saying we've got two parents that we start with. We know what their phenotype is, and we're trying to create, let's say, a stable line of that phenotype. And then we look at the phenotype, so you get the F1 generation, and you can pick whatever ones you want from the F1 generation, knowing what their phenotypes are, and you can back cross to the parents if you want to. Trying to lock in doing it all by phenotypic selection, and yeah, it's pretty, yeah. I don't know, man, I geek out over this shit, so that's my geekdom is playing around with this stuff. It's nice to be able
It's a good use, at the very least. Your evil genius is being pointed in the right direction. Just like, all right, maybe less weapons of mass destruction and horticulture. There we go. It's interesting how close they are together, though.
Exactly. But they say scalpel in surgeon's hands, fine tool. The psycho's hands, it's something else. But yeah, no. So hey, how are you doing, Raptor? How are things going?
I'm doing good, thanks, Pete. Hope everyone's doing well on this weekend. Yeah. Just got my last shot, so I'm pretty good considering. I feel the same as I did the last time I got the shot. So I'm making sure to stay more hydrated because I believe whatever issues I had before, it was very light. It was just due to dehydration. I just needed to drink water like you should be hydrated. So yeah, that's where I'm at with that. And just watching over my jaboticabos. I already got one showing, it's about 3 inches tall, and then it's already showing leaves. I wish I could bring it up, but there's this, it's just a big tray. And then it would be like, yeah, it'd be weird. But once they grow larger, I actually need to take pictures, so I will do that. And yeah, what else? Everything's doing well. Getting everything set up, ordered a bunch of pots for my outside garden and my inside garden. I'm actually using the same pots GMF is using, but I wasn't able to find the, I believe it's 11.9 or something like that, the diameter. But yeah, I was able to get 9.7, so I got it. Yeah, just a 20 or so. It's not a big deal. Yeah, actually, I got 28, and then the rest, the other 8 are for family members. But yeah, I share a garden with a family member, so it's cool that she's into it as well. And especially finding something that's going to allow me to maximize all the water I have. And I live in California, if anyone doesn't know. And yeah, water conservation is very big in my plans. So I will be later on collecting water through the roof and however I can, manipulating my land site so that I can capture more water as well. So yeah, that's definitely something that I'm looking into. And yeah. Speaking of water, that's a really nice background you got there, Kanja. I need to set up my my audiovisual skills. I need to make them a little more keener.
Yeah, man.
Yeah,
Cheers,
that
guys.
makes me jealous looking at that. Like, makes me question why I left that sort of environment for the ones that.
Not too much longer, man. Not too much longer. Yeah, let me know when you head over to Southern California. We'll make sure to uh, set up a nice schedule of like sites to see.
Yeah. That's exactly. That'll be fucking perfect, man.
Mm.
Fingers crossed. Not too much longer. Not too much longer.
I recommend the winter slash spring. Everything's waking up, and you can grow all 4 seasons here. So the winter here is more like a nice spring where all of Northern Americans are concerned, like the northern part of North America, I should say, right below Canada area. Yeah, I've seen how beautiful it looks up there. Yeah, super envious of all you Northerners that are just getting out of the season, and yeah, the mushroom season actually ended, or for most of the varieties. But there is a season to each mushroom, and there will always be mushrooms in every season. But there is a peak, which is typically winter, spring.
Yeah.
You guys get it much better than we do. But I'm in Southern California, so I just need to work on conservation of my local area for water, and eventually that'll bleed through into just like this ravine, and we can have lots of mushrooms ourselves. So yeah, first I'll build up my library and spread the spore.
Yeah, cool, man. Sounds good. It's definitely getting nicer here. I mean, it's still light. 9 o'clock. It's getting to that time of year where it'll get past 10:30, 11. It'll still be light outside, which is quite freaky. The first time you experience that coming over here, from where the latest it used to be light would be like 9, in the height of summer, maybe 9:30 at a push. Yeah, it was very bizarre coming here. I can experiencing that for the first time.
Yeah, it'd be weird. Looking out 9 p.m. and it's just now settling. It's more like 8 o'clock for us. So it's not too, not too big of a difference. But once you just look at the clock and like look outside, that's
in a month's time, it'll be even more. It's something like, well, no, actually, we're coming up for? No, we're coming up for the summer solstice. So that's coming up in another 15 days or so. Yeah. So we're almost getting it. The longest day,
nice.
Shortest night coming up.
Shout out to all you pagans out there.
Yeah, I guess I'm technically born in spring. Interesting. Late spring.
Yeah, because we had the summer bank holiday just been. And hey, JMF, how you doing?
Man, it's red letter day, dude. I can't complain. It's been a very good day. I don't know, some of you guys out there probably know that I do a lot of public health work and community work. And today we got to do a COVID clinic trying to get needy populations vaccinated. And we got an extra 7 people off the street vaccinated. So I don't know, man, I'm feeling pretty good. It's a red letter day. We get, making the community better one little bite at a time. Right. So yeah, it's a great day, man. I just feel fortunate I get to be here hanging out with y'all now. So yeah, good day, man.
And Mr. Ganja Grover. That guesses what you grow there. Tomatoes.
Cheers, all. Yeah, just sweating my ass off here in fucking New England. It's hotter than hell.
Gotta work for that dollar, hey.
Yeah, I'm just looking to sort through Starstruck. I'm actually kind of sorting through the phenotypes of that right now to pop into flower after Rasta Jeff gave me some tips on what he liked. He liked this droopy variety that just doesn't. It's a really droopy, big leafed variety that he asked me to find, or told me to find, because it was definitely a good expression. So I think I'm cloning that, and I think I'm gonna flower that solely. And I think the other stuff is all going to the back seat because he said, the other stuff is great too, but he would focus on that big flowered, that big leafed varietal that just looks droopy. It's so much different than everything else. So see how that goes. I'm excited for this because I love that Starstruck cross.
Yeah. Well, that's kind of the thing. Like, I mean, that's sort of quite topical to what I want to sort of show and discuss. But yeah, otherwise, how things going for everybody else on their plant side of things? How's your DMF? How's yours going on the breeding side?
Oh, excellent. I've been popping through my Pakistani Chitral coached by Golden Goat. And right now I'm just looking for a male to run with that project. And it's kind of hard, just typically, like, we're always used to hunting for females, but now I have to find a male in that population. But typically, yeah, I mean, dude, I can't complain. I have way too much fun breeding. I have way too much fun seeing, what comes out of it. Right now I have one of my crosses. It's PCK by Superdog crossed to PCK by Biodiesel. So we'll see what it's like having the same lineage on both sides. That's my most recent one. Just popped a tester of that. I only got I only did one female out of it. I popped probably 20 seeds just to check the viability of the seeds. They all came up fine. So I ended up just keeping one of them because 5 plant count. I ended up keeping one of them just to see what it comes out like. But yeah, pretty excited about that, man. And then everything else I've been playing with the deep chunk, watching for that. It's funny. I was talking to anyone out there knows Ozzy. He's been doing a lot of plant work, and we've been walking over like, okay, if you're breeding specifically for what I'm doing, which is for a plant that throws roots like nobody's business, where I'm actually breeding for hormone expression. So yeah, it's kind of neat looking at again, tailoring into what you're talking about here today. It's watching those identifiable morphological traits, like what I'm tracking in the chunk, throwing roots 4 or 5 feet off the ground, and it's trying to grow roots. So yeah, I think it's coming along quite nicely, I should say, because I'm seeing roots pop in all kinds of different things in places I wouldn't expect. So I'm hoping that this high hormone level is being pushed along into the progeny from deep chunk.
Yeah. Well, there's only one way to find out here. That's going to do it.
And give away some seeds here pretty soon. Gonna have to send some more samples out and get them other people popping them.
Yeah, no, cool. Yeah, well, that's just it. I mean, the more people you can do, get popping it, the better. And then all recording all that information about all the environmental data to go with it, so that you understand, what's true to the genotype. I guess something that just appears everywhere. That's less environmental dependent. That makes sense.
One reason I'm grateful for this every Saturday, man. Just helps me in my own personal projects by making sure, the brain's getting bumpier and bumpier every Saturday. So thanks for all your work, man.
Brain's feeding full, man.
Yeah. Ain't no smooth brains up in here.
No, exactly. Yeah, so sort of on that note, I mean, like when it comes to doing the selection process for a breeding project, so I guess the traditional way of doing it is you grow them out. You take your 2 plants that you want to breed with because you like what you see in them. You cross them, you grow them out, and then you have a look at that offspring and you go, okay, so from this offspring, I pick the ones that I like the look of, that seem to have the traits that I'm interested in, breed those, breed out all of that generation. After doing that, you then pick again 2 plants, whatever it is, you pick until you find what you're looking for. But let's just keep it simple and say you pick 2 plants from that generation that you like the look of, that have the traits, until every time you do it, all you're seeing is the plants that have your trait in it. That becomes its own line at that point, because no matter how you cross it, you always just get the same thing turning up every single time. And so yeah, that's the sort of the traditional way, doing it visually, I guess. And stop saying all the time. So to that end, simulating it. So we have a bunch of genotypes set up here, and I just did it as 2 parents in this case, where they're both heterozygous but equally heterozygous, so they would express exactly the same phenotypic trait if you grew them out. So you could almost take this looking like this could be a selfing project. You've taken cut from the mom, and then you've got one to pollinate, produce pollen, you're going to pollinate the other one, so it's a like for like that you're sort of crossing with. just for the first run of doing this, we're just going to restrict it just the first 2 genomes. So it's just going to be using these 2 genomes, and we can assign different phenotypes. So it'll be tall and broad as in broadleaf, and it'll also be short and narrow as in narrowleaf. Both of these are going to appear. The P parents will look like tall and broadleaf. And the idea is to try and create a pure stable line of tall broadleaf plants, and only doing it by visual selection, no other means of doing that. And we're going to do it, grow 20 plants, pop 20 seeds and see what we get. So you've got this parent, which is tall and broad, and that parent that's tall and broad. And when we cross them, the fact that we suddenly get this variety in the F1 generation tells us straight away, okay, we weren't working with homozygous parents. So this is where it gets difficult now, because the second you do this first cross, it's just chaos. And this would be typical of anything that you're using these days. It's going to be very rare that it's the chance that you'll cross 2 plants and everything that comes out completely stable, unless they're both being, which will become clear, is if they've both been worked so that they're homozygous in their genes. Yeah, this is quite often going to be the case, and there will always be some variation. So anyway, the different color squares are the different phenotypes that are being expressed. Not the different genotypes, but the different phenotypes. So we're now going to have to pick 2 plants from here that are tall and broad and cross them and hope that we create tall and broad plants that are stable. We'll just pick the first 2. And we can see, having picked those 2, that they weren't homozygous, because we've got some variety in this F2 generation. It's not as much, so it's not looking too bad. But this tall and narrow, you're tall and broad, tall and broad. For argument's sake, we'll just pick the first 2 again. Yeah, if you were doing this, why not just pick the first 2 every time? The first 2 that look like they have got what you want. That's starting to look a bit better. Will we be able to lock it in? Oh, okay. And we'll do a few more. So there we go, and a few more random crosses after that. And you can see suddenly now everything is, these are all tall and broad, and it took 1, 2, 3, 4, 5, 6, 7 generations to get to 8, call it 9, which is where you kind of proved it by starting to do random crosses, just anything with anything, and it just produced the same. And that was just to lock in 2 traits. When you add in trying to do this for a larger number, trying to do them all at once is nigh impossible. So the difference is, well, we talked about all the genetics and looking at the genes and the gene pool and where this is going and why it becomes that really interesting when you can link traits to a genome. And if you can then identify that genome, so if we rerun the exercise, but just, let's say this time we've got a PCR device and we can actually look at the genome and see what it shows us. So we can see straight away that, okay, this one parent is heterozygous, this one's also heterozygous. And if we want to create a stable line that's tall and broad, we want homozygous A and B, capital A, capital B. Now, at least what we can do is we can go through all the offspring that show the phenotypic expression we're looking for and see if any of them by any chance, right, there we go. We've got one straight away that we need another one, ideally. We could self it if we wanted to. But even if we weren't going to self it, for argument's sake, we could say we had to pick a male, another plant. We should be able to do this. And there we go. And you reduced your breeding down to 1, 2, 3 at most, generations, and it's done. If we'd actually done more in that more than 20, if we'd grown up more than 20 plants, we could have probably just found them in the F1 generation from that original cross. We could have found the 2 that we needed and just locked it in straight away. And this is the power of understanding the genome, the genetics, and where technology like that PCR, flow cells, and things like that. That's where this gets cool. And it should be affordable, and we should be able to do this at home. And to create a database of, this is that idea of creating a centralized database where you can send in and it says, right, this is what you've got, and this was what there is. And you can start to work out, well, if I cross this with this, I'm going to get that. Maybe that's partly, this is kind of the magic source in the Phylos galaxy, is understanding these markers linked to these traits, and so now I know how to manipulate it. Of
Nice.
course, when
Yeah,
you take,
I appreciate that you're making your own library first, just like at first it'll be like that. And I'm sure, I believe Phylos offers a bunch of information for free. So if anyone wants to understand that more, it is available for free. But just keep in mind, it's a lot of data. So have something, if you're just scrolling through, pick one thing. Just pick one thing and then go through, and you can understand it a lot better. But yeah, I really like what you did here, Pete. Just a 2-dimensional version of what they have on theirs from the looks of it when we were looking at it together.
yeah, and now this is expanding the genotype out to four different traits, and this is 100 seeds from those 4, and you want to try and reproduce a stable, tall, broad citrus green plant as opposed to purple, which is the opposite of green in this case. Yeah, and you want to do it just by eye. What really is interesting, you do the exercise and you do it by, okay, if you try to lock all of them in at the same time, so you try and find a plant that matches all of these traits, try and find two that match all of those traits at the same time. Things I can see the genome now, which is cheating a little bit. So, but when you do that, trying to match all of them at the same time, you find it just goes and goes and goes. You're down to 12, 15 generations still trying to do it when you're just doing it by eye. It makes a huge difference when you say, okay, let me just lock in like tall. And you just lock tall in, and like in 2-3 generations, you've got tall like locked in. And you might find locking tall in just happen to lock one of these other traits in at the same time. And then you're only trying to lock another one in, and suddenly it moves quite quickly, because in the process of you locking tall in, you sort of cut out potentially, that process shaved a whole bunch of things out. And you can, I mean, we just did some random ones. There we go. That got stable pretty quick onto, what did that suddenly lock into? Full broad citrus purple. So, just by getting lucky, you can do it. But that wasn't what we were looking for. You can now take one of these and back cross it to one of the original parents. So there you can see what back crossing does.
The importance of keeping genetics around. If you're going to mess around like this, this is.
Sorry, with that many things on the screen.
Yeah. You're putting that computer through the ringer there. Yeah,
so
you're one of the
that's
few
just
people like in this group that has the computation power to run these simulations, and it not take a couple days just for things to load up and process, and then you get to see one clip at a time. It's like, oh,
Dude,
great.
if I tried to make my 15-year-old laptop do this stuff that I resurrected from the grave, it would literally go to trauma counseling because I made it try to run something like this.
Now that one you could do. Maybe the other one where you have the everything munching around and bouncing around. Yeah, that's a killer. You can sit here and roast marshmallows off the back of the PC. It's definitely quite quite toasty, quite toasty. They said, "How much do you want to
Don't
see
put any
more?"
seeds on top of that.
Yeah, good point.
Well, unless you want toasted seeds on your bread.
That's true. If you want some toasted pumpkin seeds, I guess put some pumpkin seeds over there. I'm sure GMF can offer a great recipe.
Oh yeah.
I'm just reading through, trying to see what the comments here were from Magma C. Something genome is a specific function of phenotype is a visual. That must be maybe something earlier on as well. Well, the phenotype is genotype plus environment. So it's the phenotype is the outward expression of the genotype. It could also be chemotype as well, which falls under the bigger umbrella. I mean, chemotype falls under the general umbrella of phenotype, phenotype being all of those measurable expressions of the genotype.
So
And
if we steal the expression,
I'm just using these things as examples. I could have put anything in there. I could have just used colors. I probably should actually do that because I find most of the time, I use like stuff that we do, and then people go, "But that's not recessive with this." I'm like, no, it's just to show as an example, nothing more. And silence. Damn it. Yeah. And I hopefully it would be really cool. The idea there being if you could build up a database that allows you to start doing that, where you can punch in all that information, and just so you can then track, you can understand, you could see with enough info, like these traits just come with this every single time. That would be the interesting database to pull together. Yeah. Thinking out loud.
It's just awesome that
Well-
you're combining all these things, because just like with my experience in the lab, like doing any of that allele work, what good is it if there isn't another side to observe and computate everything? Otherwise we're doing this by hand, traditional routes, and then that combined with a genetic analysis combined with computation of all of this. Yeah, you're turning a decade of work into a few years. So we're really gonna accelerate things. I'm very excited for the future. You're saying though, Chima.
well, and it seems like there's really, once you've actually gotten to a point where you're expressing the thing you want to express and you have it in hand, whether, and I'm just stealing the terminology that we typically use for these Punnett squares, whether it's, two capital A's or a capital A and a small a, you've isolated. So now you've got this expression, but you really don't know between the two if you've got two capital A's or if you've got a capital A and a small a. And you don't know if that's going to be something then that you can continue to work with after that point. And the only way you're really going to know is either through multiple test crosses to actually try to verify the proof of what you just did. And even then, it's going to take you thousands of samples, as we've seen. Or on the other side of it, you just cut to the chase with a marker assisted breeding, and bam, you know exactly which one is the double A and which one is the the double capital A and which one is the capital A small a. And that right there is what, potentially years off your breeding project, if you can tell the difference between, something that's going to be absolutely dominant and, homozygous versus something that's going to be dominant yet heterozygous. So yeah, it's, this kind of really puts the division down on whether or not you're going to be able to use the technology to cut years off your project, or you're going to have to go through the old way and do mathematical proof, basically, just like we would for any kind of, science back in the day. You would have to complete it, test it, and then do proofs. At least this way, we can basically shortcut that line.
Yeah.
Instead of having to breed and breed and breed just to see what we made.
Yeah, and actually you made a point there about like the being able to check and understand what you've got, so that like that visualization of what does a back cross do. How does it let you understand what your starting material potentially was? And an example of that. So they both have the same, one of them is heterozygous, one of them is homozygous. So they both got, but you don't know which is which. So when you do the cross, they all come, all this offspring look the same. So you then pick two of these as you cross two of these, thinking you've got one, struck out, and suddenly it's like, oh, hang on, now I've got this variety here, but which one of these two is the one that introduces the variety? So you pick the one that's different here, back cross it with one of the original parents. Oh, hang on, you get all of this coming out. Take one of these with variety again, take that for instance, and cross it with the other, back cross it with the other original parent. They're all the same. This is the one that is the dominant homozygous one, because it's just, so like your deep chunk, you do this, cross it with deep chunk and just stomp. It all has that. The next generation down from this will probably introduce it again, yeah, for sure. But the first generation after you cross anything with that is just tickets.
And I guess that right there is probably one of the best illustrations we've seen of what a worked line really is. Now, it's the difference between here, take this pack, you'll find a pheno amongst the however many things that you'll like to run with, versus, yeah, this is what you can expect. This is exactly what you're going to get. Don't, this illustrates, I think, very clearly why it is so much work to create stability.
Exactly. Yeah. You certainly see it takes. Yeah, you can get lucky, and that's what it does show. You sit here and you run it over and over and over and over and over again. One in every couple, it's boom, gets it, pulls it out the hat. And that's only when you're playing with a small number. So when you suddenly play with, which is the reality of it, you're playing with what, 23 how many base pairs were there again? I'm trying to remember what it was. 7 million base pairs. Yeah, it's a lot of combinations of different things. It can be, that's not all the alleles, but there's a large number of alleles available, way more than what I can do here. And the total number of different combinations is astronomical. It really is mind-blowing. It's each time it's to the power of, to the power of, to the power of, and therefore to get lucky is infinitesimally small chance of getting lucky, but yeah, you can do it. Hey, Cascade, how you doing, buddy?
Good, man. Sorry I'm late.
No worries. All good.
I was in the shower and I was like, oh, I think it's Saturday. Oh, no.
We know. Oh, we're gonna have to do a refund now for all those who were tuning in for.
He finished up real quick, got out of the shower, wiped. No, I'm sorry. Bad joke.
How many times have we told you when the red light's flashing, rent's being paid? Oh man.
How's it going, guys? Didn't mean to intrude,
no.
but
Pretty good, man.
Yeah,
We're just going over the simulations, the phylogeny trees that Pete's been setting up and demonstrating with different expressions being shown. So yeah, he even showed why you would want to backcross, what you get from everything there. So yeah, that's where we basically left off.
Yeah, that last time I showed you the I was trying to solve the problem with that piece of software. I solved it. You're all gonna get to see it again. Hey, cool, because you haven't had a chance to see it. I get to show it off again.
Look at the big brain on Pete.
Not quite. So take. Let's go to 4. You've got these two parents, and you can see the phenotypic expression and the genotypic expression, and what the genotype is. And what we did earlier was showing if you don't know what the genotype was, you only could see the phenotype, and now you're trying to reproduce these two parents. You want to create a stable line. But the first time you do the cross, you get all this variety coming up. Now you just randomly select it based purely on phenotypic selection. You know, how long does it take you to reach a stable line compared to, oh, if I was using PCR or something else that allowed me to identify the genomes that went with these traits, how much quicker can I get the job done? You know, and its magnitudes quicker. So here, being able to just, you pick two. Hey, we might have struck it lucky. Hey, there we go. An example of getting it lucky. Not always the case. And then back cross it with one of the parents, and boom, variety. Cross it with one of the other parents. And this is only, this is 100 or so. It generates something different. There we go. A whole new phenotype being expressed that we hadn't seen up until now suddenly appears. I didn't even know that purple was in there, for instance. The first time we're seeing purple. It looks like purple allowed it to lock it in fairly quick, and then you could again back cross it to one of the original parents. That you would know that's definitely a recessive trait that you found there, because it just doesn't show up at all. And these are, well, this is only 100, so maybe if we did like 1,000, maybe one of these is carries a recessive gene on it, but popping only 100, we didn't hit that point. We didn't actually see enough to get there. And then it gets really crazy when you say, let it rip for all of them.
Wow. Looks like United
randomly.
Colors of Benetton ad.
They're randomly picking until you might. No,
Dude, I like this rainbow layout. It's Pride Month. This is awesome.
Maybe that.
Oh,
Oh,
Well, so here we go. Here's a prime example of just,
yeah.
hey, let's take as many years as it takes. We don't know, to try to mix things up and see what we like out of it.
This is like open pollination, just randomly selecting on each generation as it goes. Sometimes it will hit one where, again, just by pure fluke,
right off the bat.
Now, what you might have, what might aid that selection process is these things might happen. They might land in an environment that genome does better in. Maybe it grows a little taller because there's other weedy plants around, and because it's getting taller, all the tall ones suddenly succeed, whereas all the short ones die off.
Is that what you're seeing happen? Is that what we're seeing happen in these consistent color lines? Like, for example, in this whole setup, you've got one line that's consistently blue, light blue. You got one line that's consistently light blue with a little red, and one line that's red with a little light blue. And those three lines are anomalies in that the limited number of expression they carry compared to every other line. So what is accounting for that solid blue line, or that blue with mostly red, or red with just a little blue?
It was just a lucky choice. I mean, let's have a look and see what parent was selected. Okay, so that was one parent.
This is interesting.
This is how important selection is. There you go.
Because what a genetic fluke. You have one entire line of blue.
Yeah.
And that was the other parent. So, and the other parent, oh, you see, now this parent is homozygous.
So one parent's homozygous. What about the other?
The other one was heterozygous, and that's why
we got, okay.
Yeah, the other one's heterozygous. And oddly enough, again, it wasn't enough plants. I reckon if we did this with 1,000, it would change again. Again, it would get more difficult. Well, it must be more difficult, but on the random selection side of things, yeah. I mean, it keeps the population genetics going for a lot longer.
The one that was homozygous and the one that was heterozygous, the heterozygous one was dominant for the same gene that was in the homozygous? Is that why it went all blue?
So we've got. Well, this is what's interesting because okay, they're all. Yeah, is it a slightly different shade of blue? That's the other question.
Oh, to me, it all looked like the same shade.
You
I'm
know, I
sorry.
agree. It probably is, but it's randomly selected. Well, it has a consistent color palette, but it's random. You know, so the shades of blue could be close, but that could just be by chance. I'm just.
Still, this is such an interesting one that you
Well,
came
I
up with
crossed it
here.
again. We've got the same result.
Yeah, just because we get that one line that's nothing but consistent expression.
Yeah, it's all got.
And then it's the parent generation, a slightly
Dominant.
expression mixed, and then the great grandparent expression. The grandparents look like every other line.
It's
3,
still
4
really
expressions.
muddled up, yeah.
This is a really interesting one you're in, Pete. This is in particular is absolutely fascinating. I could stare at these for hours.
Oh yeah, I have been. Make it 50, and it's. I mean, yeah, it's quite a few.
This is fantastic. Because what a better way to illustrate what we're all trying to actually mentally wrap our heads around. This is awesome software, Pete.
And then you just do a random selection. Yeah, this is just open pollination. Oh, there we go. That fun, but no. And it's amazing how you think, oh, maybe it did it, but it's again, because it's just all showing, because this is phenotypic expression. It's not, we're not looking at the genotype, we're looking at the phenotypic expression. And that's, you know, that's partly what this shows is that catch.
But this is exactly what we would see happening in a small localized landrace going through its, natural evolutionary cycle.
Yeah, if it was just one plant, that's all that in every generation, it was just two plants that pollinated each other, and that was it. This is the sort of trend you would see. Yeah, this is what could happen. And again, the smaller the gene pool gets, the quicker the variety gets chopped out. The second one selection can just, that's it, it's all gone. You don't get it anymore. Yeah, one member of the population dies out, and whoop, that trait just vanished, and you never get it back.
Do you
Again,
do you have the ability to go from 100, 100, 100, 100 to 10?
To simulate a catastrophic event in an environment. Yeah, that's not a bad idea.
Well, a land race, a 10 pack of seeds.
Or it could be geographic divergence. Yeah.
I can just do it as a 10 pack. I mean, you can go, it's the same, so if you go, instead of it being this, 100 seeds that you popped, well, 50, what did I change this down to? Was 50, I think. We go, okay, a 10 pack.
Yeah, it's just the difference, because usually, like, I would take a 10 pack to 500, but I wouldn't pop all 500. I'd pop 50, though, So
the 10 pack, through random selection, you haven't seen all the different phenotypes being expressed anyway. Yeah, I mean, you only saw when you pop 10, 1, 2,
yeah,
3 phenotypes got expressed. That's it. Now, there are way more phenotypes out there, but that's all you've got to work with for what you're going to select. And so very quickly, it's locked itself in.
Good illustration of bottlenecking.
And you'll never be able to get after this point. Yeah, it's gone. You can't get narrow leaf. You can't get purple because it's all dominant.
Right. Which is why open pollinating your 10 pack is so important.
Again, it can do it really quickly.
Right. That's the point, though. That's the lesson to learn.
Or that's another example. It takes longer. Yeah. In fact, and there was an outlier in there.
Interesting. What is that outlier?
That's still only 7 generations though, and then it's a wrap.
Yep.
Wait for it to catch up or pointing.
And that's 1-to-1 selections. That's the problem with 1-to-1 selections.
But then again, if your
The other
goal
example-
is stability, that's actually not a bad way to get, or is consistency. That's, it's a blessing and a curse, double-edged sword,
Right.
It's like a knife. Sometimes it feeds you, sometimes it hurts you.
And that's the other example of it running as a simulation where everything is moving around and pollinating, and so things are dying and going on. So certain things are a little bit more successful than others based on shape and size. And this is the one where you can then program some rules into it to have, okay, this area, if it falls into it, is more favorable for this genotype, and you just watch how that thing just gets populated by that genotype. It just takes over. And if you have areas that butt up against each other, you find some genotypes learn, oddly enough, how to exploit it because they've got traits that work on both, and they double up if they fall across the line. So yeah, I start moving things further apart. So yeah, instead of that being a 1-to-1 random selection, this is open pollination in its more true form and on how it would be going on, where you've just got whatever hitting whatever. It's probably really small on the screen, I've just realized.
We can all zoom in.
And I will put the software up on GitHub, actually. The life simulator that's, yeah, I think there's a version up there already. I'll have to add another one in, and then I'll put that other chart one up that does the F1, F2 generations.
It'd be interesting to
documentation.
It'd be interesting to throw a line of code in there that told it every, like if you had it set for hundreds, if it told it every, like, I don't know, 8th generation, 10th generation to pick 10 and then go back to 100. Sort of like
only generate 10 seeds on every nth generation.
Right.
Yeah. Yeah, that's not too difficult to do. Yeah.
Just so you could see, like, population, something happens, population, and see the effect.
Yeah, I need to get more familiar with some of the software I'm using here so I can have it scroll up the screen as well. Because you think, shit, I've run out of space. You turn it into a top-down arcade like platform game. Pick your generation. I mean, that's it. Get from 8. Here's your starting point. That would be a fun game. I say fun game, for us growers and breeders, where the challenge is you're given this plant to start, these 2 plants to start with. You can see the phenotype of these 2 plants, and you're told what we want is this as a stable line and piece. And the challenge is who can get there the quickest, doing nothing but looking at the phenotypes and making the selection criteria as they go. And you'll see eventually you'll get to a point you go, fuck, I've made a mistake somewhere because I just can't get that.
If you do that, you have to have a leaderboard. You have to.
Yeah.
Screen names and leaderboards, mandatory. It's bragging rights. That'd be fun, man. That'd be a
Good. Yeah, so copywritten, ideas being copywritten here first.
Okay, this just occurred to me. You basically made the game gin. You have a gene pool. You have people taking cards out, putting them back into the pool that other people aren't going to get because once they've been selected out and passed through. I mean, this is basically the same strategy as playing gin. You're looking to make a solid hand of either progressive or stable issues, whether it's numbers, whether it's suits, a lot like poker, right? That's the same thing we're doing when we're playing 5 card, but we're only playing, 1 hand versus 1,000 hands. So, I mean, we could, I do a lot of role-playing games and dice games and stuff like that as a hobby. So heck, man, we could actually potentially turn this into a game.
Yeah.
Like a card game.
Place your bets. Which one will win? Will it be the little green squares or will it be the little purple squares?
Right. And then there's an element of strategy. What do you
Why
keep
does
in your
color have
hand
to
and what
come
do
in?
you discard?
Yeah. It's quite good fun to be able to plug in other parameters all of a sudden to say things like, okay, well, when it stumbles into this, yeah, say like, it lives for a little bit longer. And I mean, you can use such a small amount. You can say it just on average lives potentially 1% longer. You add 1% to its current maximum life expectancy onto it. Just the tiniest of little adjustments like that. And it's amazing the effect that it suddenly has on that genome starting to really take over. Yeah, you run it over generations because it's not something you see over five generations. It's over hundreds of generations. And that really becomes the interesting thing is you see how it spreads out in areas where it's more favorable. It just naturally just starts to happen. And that's your land races or your heirloom strains appearing out in the wild and why they're all so different from each other. And why it's probably really important to actually look at where does this come from, because it's a damn good reason why it developed the way it did. It grows best in the conditions it came from naturally. Actually, it's a bit of a hot
That's pretty
topic,
cool,
that
though,
one.
man. Pretty neat, Pete.
Yeah, someone in chat, gosh, I think it was Dozer, just put out a general question that like kind of goes into this. What's cannabis going to look like in 100 years? Like think about just the 70s, 50 years
Well,
ago. Think about those pictures back then and look at the pictures now of what's going on.
the
So
game's going to change when the universities get their hands on it. I'll tell you that right now. I already know, I can already pretty much tell you what they're going to breed for because I've already seen white papers based on what they're going to breed for. And the agricultural model they're going to use to farm it in the future. So I can give you the spoiler if you want, or we can postulate, either way.
Oh, please
by all means.
spoil. Please do.
They're going for moderate height plants that are essentially single cola. So it's just 4 to 5 feet tall, and it's cola from about 2 feet to 4 or 5 feet, so that they can plant them close. And it's an efficiency game. When you get into true agriculture, it turns into an efficiency game, and that allows them to work it commercially because they can bring machinery in because the outcome will be predictable. So once they're all the same height, the same shape, they plant them in rows spaced on a certain, like corn. And you'll look out at the field and it'll just be tops, just tops. That's all you'll see.
Somebody saying, Noel saying it'll always need CalMag though.
That's the cannabinoid farming of the future. That's what they're going to be shooting for on an industrial commercial scale.
Well, and with any plant breeding for the industrial scale, what they're really, and this is, I guess, what we've been talking about this whole time, what people are after is consistency, because that's what makes market viability. Whereas, and I mean, you're not going to get a recessive plant that's going to end up taking that over, but that could still be something so worth it to us. I keep thinking about like human beings, you typically, and I know this is a gross overgeneralization, but someone who's typically physically very strong may not necessarily, due to environmental or whatever pressure, develop the sharpest, mental acuity, and vice versa. But when you actually get those together in one individual, it's exceedingly rare. So, the question is, are these universities going to be breeding for physical traits like, that they can uniformly harvest, uniformly process? And as a result, are we going to end up with quote unquote stupid plants that really don't have the kind of punch that we would be looking for, the kind of, you know, chemical effect or chemovar that we'd be looking for, because they need consistency for processing, kind of like the
Much
tomato
like
industry.
corn
Right.
and
Or yeah,
tomatoes.
right. Yeah.
I mean,
We
name
bred them to
anything
be
in the grocery
shippable.
store.
Right. We bred out the
Basically.
flavor in order to breed in something that's much more favorable for economic purposes like distribution. But as a result, we bred out a lot of nutritional content and a lot of the more unique characteristics of things like tomatoes. So yeah, it's a very interesting question, you know.
Right. You'll see crops look similar, but they'll be based on cannabinoid type, like type 1, type 2, type 3, type 4, type 5. And they'll all look the same, but they'll be all about their cannabinoid chemovar, the chemotype profile of the plant, which will be, you know, that will determine its production value and its use and what products it ends up in. That's cannabinoid farming. That's farming for flower for cannabinoid or cannabinoids, however you want to say it. The farming for fiber will still look like traditional hemp farming, with them being spaced, you know, 6 inches apart to grow as long as they can, with stretch the internode strengths to get longer fibers. That's how they farm hemp. So it'll be crop dependent, but within the cannabinoid profiles that we are interested in, they'll all be shorter plants, single colas, to minimize sunlight loss, space loss, and they'll favor more of a sea of green method. I've seen it mentioned in chat. I might as well say it. They'll plant more plants closer together, have them grow shorter, but that whole zone, like if you go through a grape vineyard when they're harvesting, all the grapes are just basically lined up within this same zone the whole way down the aisle. They're going to do the same thing with cannabis. It'll all be in the same zone, so they can just process it with basically a combine.
Yeah, definitely. And then, you know, to that end, that's where stuff like this, and there'll be that's where the pioneering work on mapping out the genome becomes, so they can do it quickly. They'll get to the bottom of solving this problem fairly fast. The second they got that genome map, whoop, 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 it's done. It becomes very selective breeding. I mean, the only next step up from that, I guess, is where you're then using, what would it be, like CRISPR style technology to say, rather than going through the RSEC process of doing the breeding program to bring these genes together, we're just going to go and cut out the ones we want from where we know they are and just put them back in the sequence we need them in, and away we go. We've got what we're looking for. We can either take. Yeah.
You'll know the difference because the CRISPR ones will be trademarked or registered or whatever little symbol in a circle you want to call it. The other ones won't be. Yeah,
that'll be the like real speech market, and those will be sterile. You can only get them one place from this crowd. You know, that will be it. And then that will be the guarantee that comes with it as well to the farmer, is that these are sterile. Nobody will be able to pollinate your fields. You will have no male or no seeds in this crop.
Right. And that's the Monsanto approach, as opposed to that's the private corporate approach, as opposed to the university public approach.
Yeah. But the universities will make, hopefully, you know, what they need to do is that information needs to be put in the public domain. It's copyrighted into the public domain, so everybody's got access to it. What they could patent, of course, is their process for doing it, for getting from A to B. But they can't patent B necessarily, if that makes sense. If the university is showing this is how you know, this is the end result, this is what you need to do, this is the genome. Shit, sounded like the cat was killing something back there. It's not dragging something through the cat flap. Yeah, what you find is, what people will be able to do is work out how to do it quickly, and they'll patent that process, the steps they took.
So Dozer's asking about oil production, and that's pretty much what I was talking about before with the cannabinoid profiles. they'll process all that into some sort of a concentrate, and then that concentrate will find its way into value added products. I don't know, it'll really be interesting in all of this to see how common flour stays, as industrial processes get brought into this. I wonder if flowers in a jar or whatever, mylar packaging, whatever the hell, will become as rare as a nicotine pouch. Not that you can't go find a nicotine or a tobacco pouch, but that you don't see, by and large, cigarette smokers rolling their own cigarettes. They all go buy a box of cigarettes or a carton of cigarettes or whatever, however else they're smoking these days. The pouch of tobacco is pretty low on the list when it comes to all of that. So when it comes to cannabis and they start getting into value added products, and you start having, a plethora of things that get you messed up or give you some sort of benefit due to the cannabinoid content that they've bred the plant for, whether it's CBG, CBN, CBD. If flower smoking and flower consumption might really take a back seat once the industry gets their hands on this plant, that'll be kind of fascinating to see it, because it's definitely easier from a manufacturing perspective, and it's more profitable for them to turn the flower into a concentrate, use the concentrate to make something else, and sell you the value added because they did the work and made this other product with it. The only catch is they have to make those other products appealing to somebody who's traditionally consumed flowers. But with the rise of rosin and dabs and all, it's obviously not that hard. So it's going to be really interesting. That's the part I'm not sure about, is will you be able to find flower in 20 years, or will you only find a whole bunch of cannabis products and not really even find flower?
Here's what I'm sure about. As humans, we are ruled by convenience. Most of us don't want to take the time to do things that we can far more conveniently get. Most of us don't bake our own bread. Most of us don't make our own beer. There's a very small slice of us in the population that do actually make things for our own consumption versus just participating in this larger productive system. So, and even then, you're always going to do it in different ways and partially. So I don't know that, the future, anything's going to disappear, but what exists and what is common is always going to be determined by our own desire for convenience. So if, again, since smoking in public has, become literally not considered a healthy thing to do, but vaping seems to be tolerated, you might see the future where plants are literally harvested and pressed all on a combine, and all that's coming out of the back of that combine is a tanker full of oil. Or, one tank of oil, one tank of water, basically, after processing. So the combine is basically, I grew up on a farm, the combine basically comes along and does all of the process in and of itself. It takes the stalk, it takes the corn off the stalk, and basically a lot of them will even just remove the kernel right off the ear, and you simply put that into a hopper. I don't see how in the future of industrialization you're going to get around having literally a combine or harvester go through a hemp field or whatever kind of field you want, and it's going to literally do some of or all of the processing right there.
You're going to have it down to like the Dutch floating lettuce farms where it's all done on hydro. These things are the size of football fields, and the time it takes the plant to be pushed, float along from where it gets dropped on to where it gets lifted off on the other side is how long it takes it to reach maturity, get to what they're looking for. And it's just a constant conveyor belt. There is no one in, one out, and it just goes on and on and on, and that's it. The lifetime of the plant is time to be the duration it takes to get from the start to the end. And as you say, you combine that with something like you're just growing one cola. It's not a big bushy plant. It's just one cola with a root structure, almost perfect for, again, growing in like DWC type setups. Big pools of the stuff.
Buddha Boy in chat makes an excellent point. Tomato paste does not take the place of sun-grown or hothouse tomatoes. He's absolutely right. But look at what people consume. We consume a lot more ketchup than we do actually eating tomato. Like, you're not going to sit down and eat a tomato, but people put ketchup on literally everything in this country. It only recently lost its spot as our #1 condiment to ranch dressing. So while that's what I'm saying, these flowers, these craft flowers and things will exist. What most things are getting processed into is going to be whatever is the most convenient form of consumption for the masses.
I don't think the market, I mean, and therefore the market is no different to any of the other markets that, if you want to know what it's going to look like, we'll look around, look at what every other fruit and vegetable market looks like right now. You have the convenient supermarket angle of it. You've got the tomato paste in the tube, but you also have the artisanal sun-dried on, Mamacita's ass cheeks and the Italian sun. You
So
still got
tomato
those
cobs
options that are out there. So I do actually think it won't be actually any different. But that's part of the almost like the reality of it. If you want to know what's coming, just look at every other industry. As the fruit farmers, I forget what they're, cranberry farmers. When cranberries became the hot shit, cranberry farmers were making a killing. But then cranberries, everybody was growing cranberries, and the price just tanked. I mean, they would turn around to the cannabis market and say, if your business model is $5,000 pounds, you're not going to do it. You need to look at does your business model support $500 pounds? Because this is exactly what's coming. It's not like it won't happen. It's inevitable, unfortunately. It's that grind of what is coming. So yeah. It's just looking around to see what else is out there.
Well, that just makes all the work of gathering genetics and make sure we mark and log everything that much more important, so that we'll know, hey, this does lead this way, but we still have other genetics to make sure we can go back to, like heirlooms. Everyone, it seems to be like that's just how it's going to be. We're all going to be heirloom heirloom gardeners, heirloom collectors, whatever term you want to go into in terms of what you're looking into. But yeah, I think that's the only way it's going to be saved.
Areas where like cooperative communities have just agreed just to do open pollination in their areas, so you get like this natural selection of plants that are naturally suited for that environment, and you get these heirloom bits popping up. You may only select the ones that you want to keep for next year that look good this year, sort of thing, and that way you're passing it on rather than all being done indoors and small little sets of genetics being played with. Yeah. As we see this, like, sad thing is when it's gone, it's gone.
Yeah, that's why I promote it. Like, if you know anyone that works with heirloom genetics or is making some themselves, that's an important work. Like we see, like we were discussing now, if you don't want bottlenecking to the extent of what we just were mentioning, well, it's going to happen no matter what. But if you don't want to use it or consume it, be part of it anyway, yeah, you're going to have to get some. Now is the time. Start getting the genetics now. Start making friends with people with vast amount of genetics as well. And yeah, try to save what you can. Now's the time. It's not, 10 years from now, 20 years from now, when a lot of it's gone.
Yeah.
Well, and just what happened to tobacco varieties. Families used to have heirloom varieties. People used to grow them. It used to be an actual appreciated thing. But once it got commodified and basically turned in a way to poison people, once it got changed from what it used to be, and it was no longer a thing that actually was grown by people, and it was something that was commoditized, it became far more dangerous and far more insidious to public health. So yeah, I think that's our consumerism and our nature with that kind of makes those things way too easy to do if we aren't intentional about saying we're not going to let that happen. I think that's the real value of all of us here, is being intentional.
Yeah. I tell you what, I think
Agreed.
we're drawing to the end of the hour. Well, it's a bit more than an hour. So if you want to join us for the after show chat and hangout, please feel free to do so. I'll post the link up now. So feel free to jump in. Yeah, you can, if you want to ask some questions about the software or whatever, feel free to pop in, have a chat with us, hang out, see how it's going. But yeah, thank you once again to everybody who's tuned in this week. Nice to see everybody here. Hopefully it was informative and that was interesting to see. I'll put the link to the GitHub repository if you are that way inclined. I'll put it in the description of the video. You can grab it there. Right now, the code is sort of, you need to learn how to read code. Unfortunately, it's self-documenting if you can read it. I will work on putting some documentation together to make it a little bit easier to understand how to use it, and then people can play around with it a little bit more. So yeah, on that note, GMF, where can everybody find you, sir?
Well, you can usually catch me hanging out here with the usual crew of reprobates in the hood, or hit me on IG if I can be helpful to anyone. Genetic Memory Farms. If you got questions about fermentation, food, cannabis, booze, anything really. Food science is the game, so holler if I can be helpful. And thank you all very much for coming out. And more importantly, thank you. I know I say this all the time, but thank you, Pete, for making this platform for us to actually have these discussions and try to further ourselves on this path. So much appreciated, bud. Thanks for making our brains bumpier.
Yeah, I bet it wants to know that we all get naked. Only when you show up, I met it. So long as you bring the money. I think that was my cat that actually was just been eating up the food bowl. I've got a sneaky suspicion it was a different one because it scarfed real quick for a second. It fucking hell. I have to invest in a air rifle, apparently. Yeah, Cascadian. Where can we find you, sir?
You'll find me here when I can find the door. You'll find me in the after show. You'll find me on Instagram at Cascadian Grow, man. Thanks for having me.
Yeah, absolute pleasure. Thanks for joining us again. And Ganja Grower out there in the fields.
Hey, cheers, Pete. Thanks again. Yeah, this is great. Like GMF said, making our brains bumpy. Well, some people's brains bumpy. Thank you very much. Yeah.
Counteract the effect of all the cannabis being consumed.
Exactly.
I remember what was said. And Raptor, where can we all find you, sir?
Thanks, Pete. You can all find me at Raptor Grow, all one word, all lowercase, at Instagram, and also you can find me on the neighborhood. That's Mondays, 4 p.m. Pacific time, 7 Eastern, 12 UK. And yeah, you can find me at the show, same time, same place, 1 p.m. Pacific Standard Time, 4 Eastern, and 9 UK. Yeah, great to see you all.
Oh, cool. Yeah, so that's
Great discussion. Got really into it.
Neighborhood Grows again. What day was that? Sorry, it sort of broke up a bit. I mean, it did break up
Mondays.
for me. I don't know if it did for everybody else.
Oh.
Mondays at
Mondays at
midnight
4
UK
p.m.
time.
Pacific Standard Time, 7 Eastern, and 12 UK.
Yeah, exactly. Cool. And you can find me at Operation Grow 2019 on Instagram, or at PL Grow Systems on Instagram. Also the website plgrow.systems if you want to get yourself into monitoring your grow environment and understanding what's going on a bit more. That's the place to go. And on that note, if you do want to join us in the after show, the link's being posted up. I'll post it up one more time just in case you're looking at top chat or something rather than live chat. There we go. Join us in the after show, and we'll catch you all next week. Thank you very much.